Hi rabbits, Research Turtle here. Today, we are going to trace the pulse of civilization by looking at the evolution of energy mobility. We often think about energy in terms of generation, solar versus coal, nuclear versus wind, but the real story of human progress is actually about mobility. It is the story of how we liberated energy from the chains of matter and moved toward the freedom of the field. Let's start at the beginning, the biological limit. For most of history, energy was heavy. Whether it was wood or muscle power, we were constrained by weight. Wood has an energy density of about 15 megajoules per kilogram. This meant that urban growth was physically restricted by how far a human or a horse could carry a log. Production and consumption had to be geographically identical because the cost of transport was too high. We were tethered to the forest. The Industrial Awakening loosened these chains, but didn't break them. Coal gave us a jump in energy density to about 24 megajoules per kilogram. We replaced the horse with the steam engine, dropping the demand for horses by 90% in just 2 decades. But look closely at the steam engine. It began as a tool to pump water, yet it became a machine whose primary job was moving the very coal that fed it. We were still hauling matter to create energy. The true disruption came with the war of currents, the battle between mass and charge. On one side, you had Edison and direct current. It was low voltage and suffered from high heat loss. It couldn't travel more than 5 kilometers. On the other side was Tesla and alternating current. By stepping up voltage, Tesla allowed energy to travel hundreds of kilometers. Tesla won the 20th century because he successfully separated energy from matter. He built the grid. But as we step into the 21st century, Tesla's AC grid is becoming a bottleneck. We are facing the skin effect, where current only flows on the surface of a conductor, wasting the core material. Worse, we have a capacitance problem that limits subsea AC cables to about 80 kilometers. You simply cannot build a global energy network with those limitations. This brings us to a fascinating irony. Edison is being vindicated. We are seeing a renaissance of high-voltage direct current, or HVDC. Thanks to modern voltage source converters, we can now control voltage and frequency independently. This technology eliminates the skin effect, using 100% of the conductor, and it has no capacitive loss, meaning we can transmit power over unlimited distances underwater. We are moving from a regional grid to a global one. To supercharge this, we are looking at superconductors. Imagine a cable just 17 centimeters in diameter, the size of a dinner plate, carrying 3.2 gigawatts of power. That is the equivalent of 3 nuclear power plants flowing through a single pipe with zero resistance. But hardware isn't enough. We need intelligence. We are moving toward the Internet of Energy. Just as the Internet breaks data into packets, we are beginning to break electricity into power packets. Energy routers will read headers containing source and carbon footprint data, allowing us to asynchronously connect microgrids. This digital grid stops cascading blackouts and treats energy exactly like information. Now, what about storage and transport where wires can't go? We look to molecular carriers. Hydrogen offers high density, but requires cryogenic temperatures and suffers significant efficiency losses. Ammonia is easier to liquefy, but is toxic. Then there are liquid organic hydrogen carriers that use existing oil infrastructure. The reality check here is that the round-trip efficiency is only 30%. These are not for daily driving. They are the batteries for global shipping. Speaking of shipping, let's look at the ocean. We are breaking the tether here, too. Traditional subsea operations required a mothership and a heavy cable. The future is autonomous resident systems. We are developing subsea gas stations, wireless power transfer hubs on the ocean floor that charge autonomous vehicles with 85% efficiency. We can even harvest energy right there in the deep, using the temperature difference of the ocean water or deploying underwater small modular reactors. Finally, we look up. The ultimate energy source is the sun, but on Earth we contend with night and clouds. The solution is space-based solar power in geosynchronous orbit, where the harvest is 24/7. Projects like Caltech's MAPL are already testing this. We can beam this energy down using microwaves, which penetrate clouds, or lasers, which offer high precision for places like the Moon, where there is no atmosphere to interfere. So, where does this leave us? We are witnessing a paradigm shift in 3 acts. We started with matter, coal and oil. We moved to the grid, HVDC and superconductors. And now we are entering the era of the field. The future isn't about moving fuel to the user anymore. It is about the user accessing the energy field, wirelessly and instantly anywhere in the universe. That's it for today. Turtle out.